Quantum Laser Pointers brings you the infamous double-slit experiment right in the palm of your hand. In 1801, English physicist Thomas Young performed this experiment to determine if light was a particle or a wave. A laser shines a coherent beam of light through a film disc containing two parallel slits. Light striking the wall behind the slits produces a classic interference pattern. This surprising result means light passes through the parallel slits not as particles, but as waves.
Visit our website or subscribe to our YouTube channel now. Be among the first to see our new line of double-slit lasers, quantumlaserpointers.com.
I suppose I got to the stage when I should indulge in looking back as well as hopefully still looking forward to my future work. There are some people who end up as astronomers who right from the start knew what they wanted to do. I wasn't like that at all. When I was young, I was interested in nature and also in numbers, but I don't think I had any conception that I might end up being a professional scientist. But I could think of two things which puzzled me when I was a child, which perhaps showed I had some interest in science. One was extremely mundane. I remember watching the behavior of tea leaves in a bowl of water. And you know, if you spin a bowl of water, the tea leaves pile up in the center, at the bottom. And I remember puzzling about this. In fact, it wasn't until I was a third-year undergraduate I understood why that happens. But that was something which puzzled me. And I also remember on summer holidays looking at the tide tables and not understanding fully why high tide was different in times at different places around the coast. And there again, that's something which I puzzled about when I was young, and of course only when I got to university did I understand the reasons for that. So I suppose, having thought about things like that, that indicates that I had some propensity for doing science and worrying about things. I turned out to be good at maths, and therefore I was urged by my school to apply to study mathematics at Cambridge, which I did. But actually, I've always regretted having done that, because I think I would have done far better to have had a broader science curriculum. The science I've used in my career, I've sort of mugged up as I went along. And it was clear to me when I was an undergraduate that I was not cut out to be a mathematician. I wasn't enjoying it. I was into the applications. And so when I got my bachelor's degree, I thought of how I might use my talent in mathematics to do some subjects where I could have a more synthetic and synoptic style of thinking. And I thought quite seriously of doing economics, but I instead decided I would do astrophysics. And this was really a bit of luck, because I knew nothing really about astrophysics. I got a research grant to be based in Cambridge for my PhD, and I was allocated to Dennis Sharma as my PhD supervisor. And this was a piece of luck, because Dennis Sharma was the most charismatic person who was in touch with what was going on, and he had a very good stable of students, as it were. Even though I was diffident about whether I was doing the right thing, within about a year I was fairly confident that I was going to get a PhD and that I was doing a field that was interesting. And that's because I was lucky that this was a time when new things were happening. The first evidence of the Big Bang, but also the first evidence for black holes. And one of the earlier phases of my work was in trying to make sense of these extreme objects and to understand why they were radiating and how they were able to be so bright. I was lucky in a way to be appointed a professor at a fairly early age, and in my 30s I already became director of the Institute of Astronomy for a period. This gave me some obligation to have a broad view of the subject, and I appreciated that. In retrospect, I feel I was not experienced enough to do a very good job in that role, but I'm happy that things seem to thrive and no disasters happened. In Cambridge, I derive great benefit not only from my own research but from participating in the debates. I think I've been someone who enjoys collaboration, and that's not just because the other people do most of the work, but I think less cynically because the subject does evolve through a collective effort. It's a collective enterprise, and I've been fortunate to be able to take part in the debates about all these subjects and to see how originally speculative ideas gradually come into focus and become firmed up as a combination of new data and new ideas. Going further on in my career, I was lucky in that many of the issues that I started to think about as a graduate student have continued to be the focus of my interest throughout later decades, understanding black holes, understanding the Big Bang, and other problems like that. But one issue that really became important in the 70s and 80s was understanding the so-called cosmic dark matter. It became clear that there was more in galaxies than the stars and gas we see, that to understand how they hold themselves together under gravity, there had to be a lot more stuff producing gravity than what we see, and this was the first evidence for dark matter. And I was one of the people who was involved in some of the early work on this so-called cold dark matter theory. When I was getting to the age of 60, I realized that perhaps I ought to do a bit more in the way of sort of general service to the university and outside, and I consciously tried to do something like this, but in a sense I tried too hard because I ended up having various other obligations, which meant that during the last 10 years I've probably had less time for full-time research than I'd had previously, because I became head of a Cambridge college, Trinity College, for 8 years. That was very stimulating because it's a marvellous concentration of academic talent across all fields, so I was very good for my education. And I also had the chance to be president of the Royal Society, which is a 5-year commitment, which of course again involves a great deal of involvement across the field of science and international contacts. And I became a member of the House of Lords too in 2005. So those three activities diverted me from astronomical research, and having shed them, I hope I'm not too gaga to be able to go back and spend a bit more time doing research than I did in the last decade. Another thing that I've done over the last 20 years, and which I'm glad to have done, is become more involved in outreach and presenting work to the public. I've written a number of books. I've been editor of an encyclopedia that sold 500,000 copies, and I feel I've made a contribution through speaking and writing about astronomy to general audiences. And I think I'm lucky in that the subject is one which does attract wide public interest. There's a huge amateur community, of course, and there's a lot of intellectual interest in the fundamental issues of origins. Where did the Earth come from? Where did life start? Where did the Big Bang come from? In my writings, I've really tried to address some of those big questions. I think it's possible to predict 1 decade ahead what we'll be thinking about. I shall myself be hoping to take a greater interest in planets around stars, because in my institute here in Cambridge, we have one of the world leaders in this subject joining us, and we're starting a new group in this subject. So I hope to learn a bit from that, but I hope also to continue to work with colleagues on clarifying some of the issues which are still mysterious about extreme phenomena in the universe, gamma ray bursts, black holes, etc., and learning what we can from new computer simulations and new observations. I now find myself for the first time in more than 30 years not responsible for any institution. I'm not head of a department or head of a college or head of anything like the Royal Society. And so I suppose I can be more outspoken and irresponsible in a sense. And one thing which I hope to do, as well as continuing with my science, is to get involved in some political issues that I care about and get involved through various campaigning organisations and through the House of Lords.
Be among the first to see our new line of double-slit lasers, quantumlaserpointers.com.
When I was young, I was interested in nature and also in numbers, but I don't think I had any conception that I might end up being a professional scientist. But I can think of two things which puzzled me when I was... I suppose I got to the stage when I should indulge in looking back as well as hopefully still looking forward to my future work. There are some people who end up as astronomers who right from the start knew what they wanted to do. I wasn't like that at all.
Slits. Light striking the wall behind the slits produces a classic interference pattern. This surprising result means light passes through the parallel slits not as particles, but as waves.
Visit our website or subscribe to our YouTube channel now.
Quantum Laser Pointers brings you the infamous double-slit experiment right in the palm of your hand. In 1801, English physicist Thomas Young performed this experiment to determine if light was a particle or a wave. A laser shines a coherent beam of light through a film disc containing two parallel